Today we will be looking at the one sample z-test for proportions. Prior to spring break, we were working with a confidence interval, creating an estimate based on data. Now we've transitioned to a hypothesis test. In a hypothesis test, we are going to test a claim using data. When we're working with a hypothesis test, we're going to start with an initial belief, and then we're going to gather data. We've added some steps to our 4-step process, so our hypothesis test will actually take 6 steps. Some of the steps are very similar to what we've already dealt with. Step number 1 is to name our process. Again, like before, we'll have multiple processes that we'll look at, but first we're going to look at categorical data. So the name of the test that we're going to work with today is called a one-sample z-test for proportions. It is also known as a one-proportion z-test. Yesterday, we looked at writing hypotheses, and that is our step 2. Our null hypothesis, a statement of no difference, no change, nothing is going on. Since we're dealing with categorical data today, we're going to be using the symbol P. So our null hypothesis is P equals whatever our number is. Our alternate hypothesis, what is indicating change, that it is less than, greater than, or not equal to. Do make sure that you define your variable. You need to make sure that people understand what that P stands for. So P is the true proportion of whatever our situation is. Step number 3 is one we have actually seen before. It's our conditions. Remember, with categorical data, we have to check for good quality data and normality. Good quality data is found through randomization, that we either have random sample or we have random assignment to treatments. Normality with categorical data, we go back to our successes and failures. We need a large enough sample that we have 10 expected successes and at least 10 expected failures. Do make sure you show those numbers. Step number 4 is to do the math. As we saw on our globe toss, this is really just a z-score. The test statistic formula is z equals p hat minus p over the square root of p times 1 minus p over n. P hat is our sample's proportion of success. P is our true proportion for the entire population, and n is our sample size. Now, like before, we're going to be using our z-table looking up a probability, and that's called a p-value. And what the p-value actually is a probability of obtaining a value as extreme or more so if our original belief, the null hypothesis, is true. We'll work with that idea a lot over the next couple of weeks, so don't worry too much with it right now. We're going to be looking at our calculator to gather this information for the most part. So like with our confidence intervals, we're going to be going to our stat button. We're going to be scrolling over to tests. This test is called the one prop z-test or one proportion z-test. And like before, make sure you write down what you typed in and don't forget to write down your final results as well. Once we've gathered this math, once we've looked at this evidence, we have to use that information to make a decision, and that is our step number 5. When we make a decision, we're going to use our p-value to help us make a decision. The p-value tells us how unusual a sample like ours is if the original belief is true. So if our sample is really unusual, if our p-value is really low, that tells us our original belief is probably not true, and we're going to reject the null hypothesis. If our p-value is pretty high, that tells us our sample's pretty usual, it's pretty typical, and so our original belief is possible, so we will not reject the null. To determine whether or not it's high or low, typically we're going to use 5% as kind of a guess. If it's under that, that's low. Finally, we need to state a conclusion. We need to think about context. If we reject the null hypothesis, that means there is evidence of the alternate. If we do not reject the null hypothesis, that means there is not evidence of the alternate. Please make sure you remember your context. So let's look at the 6-step process with an example. Arnold Hanley is a production supervisor for the Spalding Corporation, and he claims that the percentage of left-handed golfers is greater than the 10% rate of people from the general population who are left-handed. In a simple random sample of 250 golfers, 38 are left-handed. Is there sufficient evidence to support Arnold Hanley's statement? Like before, for each step, do pause the video, try the step on your own, and then unpause to see how well you did. So step number 1, we need to name our process. We're dealing with categorical data, and we're going to use a one-sample z-test for proportions, or a one-proportion z-test. Our hypotheses. Remember, our null hypothesis is a statement of no difference, no change, nothing's going on. We believe that P, because we're talking about categorical data, is the same as it is for everybody. So our null hypothesis is that it's the same as the general population, P equals 0.1. Our alternate, something's changed. Mr. Hanley thinks that the percentage of left-handed golfers is greater than that true population percentage. So our alternate is P is greater than 0.1. P here stands for the true proportion of left-handed golfers. We need to check our conditions. Remember, we need to check for randomization and normality. For randomization, we look back at our problem, and it does say that a random sample is stated. Remember, SRS stands for simple random sample. For normality, we need to check to see if we have enough successes and failures expected. So we expect 25 golfers to be left-handed because 10% of 250 is 25. That means we expect 225 to be right-handed, and both of those are greater than 10, so normality is met. Step number 4, do the math. If you really want to do the z-score by hand, feel free. P hat is our sample's percentage, 38 divided by 250. 0.1 is the proportion from the entire population, and our sample size was 250. But honestly, we really want to use our calculator as much as we can. If we go to Stat, over to Tests, and scroll down to the one prop z test, we're going to see a screen like this. That screen, the P sub 0, that's our null hypothesis. X is our number of successes, and N is our sample size. Our null hypothesis here was 0.1. We had 38 people out of 250 who were left-handed. The next line is our alternate. Since we're interested in greater than, we're going to choose the greater than option and then go to calculate. The top two lines will tell us our z-score, which is 2.741, and the p-value, 0.003. The next two lines tell you your p-hat and your sample size. Step 5, we need to make a decision. That p-value was 0.003. That's really, really small. So our p-value was really low, so we were going to reject the null hypothesis. Since we are rejecting, in context, that means that there is evidence to support Arnold Hanley's belief. Since our question asked, was there evidence? Yes, there is. And his belief was that true proportion of left-handed golfers is greater than 10%.